Okay, so I'm going to go through sequences formed from shapes. So it shows some photo frames made with rods. So I have photo 1, 2 photos, 3 photos. Okay, so I'm asked to draw the frame that holds 4 photos. How many rods are there in the frame that holds 5 photos? Find an expression for the number of rods in the nth frame. Which frame uses 41 rods? And is it possible to make one of these frames using exactly 56 rods? Okay, so the first part of the solution I was asked to draw the frame that holds 4 photos. Okay, so what is really happening is we have triangles on top of each triangle. So I'll actually just do it out here fresh. But this here is 1 photo. Okay, to get 2 I go across and down, that's 2 photos. To get 3 I go across and down. To get 4 I'm going to have to go across and down. I'm just making triangles, so that's my 4 photos. Then I'm asked how many rods are there in the frame that holds 5 photos. So I look, okay, so in 1 photo there's 3 rods. In 2 photos there's 5. In 3 photos there's 7. And then in 4 photos there's 9, because look, you just count, you go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so then I'd be able to say the common difference is going up in 2 each time. So in my 5th rod, in 5 photos I would have 11 rods. Okay, and that's how I found out that solution. Okay, and I was asked to get a general term. Okay, so you're using this formula constantly for this. So it's T of n is equal to A plus n minus 1 D, where A is my first term and D is my common difference. Okay, so my first term is 3 and my common difference was 2. Okay, so T of n is equal to 3 plus n minus 1 D. Okay, which is 2. So it's 3 plus n times 2 gives me 2n, minus 1 times 2 gives me minus 2. So my general term is T of n plus 1. So I was asked, okay, which pattern would use 41 rods. Okay, so I know my answer, so I let it equal to. I'm not trying to find the number of patterns I don't sub into n. When I know my answer, I let it equal to it. So I have 2n plus 1 is equal to 41. So I have 2n is equal to 41